Good morning, my dear COMEDK 2025 students. This is your Captain Shreyas, and today we're going to do all the important high weightage short questions which may come in your upcoming COMEDK 2025 examination. After your KCET exam, obviously you should be giving this particular exam, and this is not just for the students of Karnataka but all over India. Some of the best engineering colleges in the country are in Karnataka, and obviously the best companies in the country are also in Karnataka. And the high paying jobs usually you will find it in and around Bangalore, so which is the silicon hub of the country. So you want to be at that place, you want to be studying so that you get placed from those companies which will give you a great package and set your life. So make sure you give this COMEDK examination with utmost sincerity, because the colleges, the top ones especially, are really good. All right. Yes, JEE 2026 will be starting very soon. Don't worry. Good morning. Hi, Shanu. Welcome, Athri. Hi, Faisal. Welcome, cadets. Good morning, my dear students. I hope you guys are fine and doing great. And it's time to start the questions of physics. Today evening, you're going to have chemistry, and then you're going to have mathematics towards, I think, close to around 7 o'clock. Yes, JEE 2026 announcements will come soon, Faisal. Don't worry. Hi Shubham, hi, good morning, Carleven, hi, Vanakam, Namaskara. Yes, let's begin. This is my small introduction. In case you are new to the channel, quickly introduce yourself and where you are from, which city, which state, and also subscribe to the channel because a lot of content is going to come up on the channel regarding the counseling, colleges, branches, studying abroad, so many things. And also smash that like button down there. Time to start the first question. Here it comes. The coefficient of volume expansion of glycerine is so and so. The percentage change in its density is how much? See, in COMEDK exam, if you have solved many models, it will click, or else you will waste time thinking how to solve it. See, percentage change in density is asked, and we all know that density is nothing but mass by volume. And whenever percentage change, relative change, it's a question on errors. Write it in the error form. So it is mass into volume raised to -1. Mass is a constant, right? So you will get basically delta rho by rho using the concept of errors. Relative error in density is mass being a constant. Don't worry about it. It will be nothing but delta V by V. The negative power always take the mod value only. Yes, take the negatives mod value only. Now, if you write it in percentage, this will become delta rho by rho in percentage will be delta V by V in percentage, but for converting it into percentage, always multiply it by 100, isn't it? So that you will get it in percentage. What is change in volume? It is original volume into gamma into delta T. Gamma into delta T into volume is delta V, that's thermal coefficient of expansion, volumetric, and yes, multiply by 100 so that you get it in percentage. Volume cancels, and I'm just left with gamma delta T multiplied by 100. Now, what is gamma? Volume coefficient is 49. So 49 into 10 to the power -5. Change in temperature is 50 multiplied by basically 100. That's it, my dear students. So this zero, these two zeros is 3 zeros. So this will become 10 to the power -2. 49 into 5, that's 15 to 5, 250. So that's going to be 245. But that will be 245 into 10 to the power -2 percentage, which is 2.45%, which is D option. Yes, that is the correct answer. D option. Perfect. All right. Amrita is also there, but I did not receive many comments on Amrita. That's why I not conducted that particular class. But if you have any requirement for that, please spam the comments. Then only I will be able to do it. Yeah, D is the correct answer. Moving on to the next question coming up on your screen. A cylinder of certain capacity contains hydrogen at standard temperature pressure. What is the amount of heat required to change the temperature by 20 degrees Celsius? That is the question. Okay. So, first of all, the cylinder's capacity is given. It is at STP is given. Heat required is asked to change the temperature by 20 degrees Celsius. First of all, let's understand how many moles are there, because that will help me solve the problem little bit better. We know that at STP, any gas occupies 22.4 liters. An ideal gas 1 mole occupies 22.4 liters. So if I'm talking about 44.8, therefore 44.8 liters will be nothing but 2 moles of gas. The 2 moles of that particular ideal gas, isn't it? That is the first thing that you have understood, that the number of moles is nothing but 2. Okay, now the question is, how much heat will you need to raise the temperature in that cylinder? In that cylinder, what will remain constant is the volume. So the volume of the cylinder will never change. So volume is a constant. So that means it is a isochoric process. And whenever you have isochoric process, the heat supplied in that isochoric process will be number of moles Cv into delta T. Number of moles is basically 2. It is given that hydrogen. Now hydrogen is nothing but a diatomic gas, and the Cv for diatomic gas is 5R by 2. So you put 5R by 2 over here, and the change in temperature is nothing but 20 degrees Celsius. Okay. So this 2 and this 2 cancels, 2 5s are 10, and this R is there, and this 10 is there. Basically, it is nothing but 100 times of R. 100 times of R. So guys, R value we already know, it is nothing but 8.31. So it will be nothing but 831 joules. 831 joules, which is nothing but C option. C for your Captain Shreyas. Very good. If you guys got it, proud of you. Come on guys, spam the answer in the chat box right away, right now. Yep. I want everybody spamming the answers. These are the kind of questions you might get, and you have to solve this in a minute or so. So if you know it, you have solved the questions of similar pattern before, it will be easy. Else you will waste time in the exam. So that is the reason why I'm conducting these mock questions for all of you. All right, moving on to the next question on your screen. The binding energy per nucleon is 7.68, and that for C13 is 7.47. The energy required to remove the neutron from C13 is, think about it carefully, the binding energy is given for both of them, and they are asking how much energy is required to remove that particular neutron. Okay, think about it. What are you going to do? Yep, think about it. What are you going to do in this particular question? This binding energy is per nucleon, please understand that. So the total binding energy for C12 will be 7.68 multiplied by the number of nucleons, which is 12. Similarly, the binding energy for the C13 will be, because this is per nucleon, it will be 7.47 multiplied by 13. Now, why is this different? Why are these answers going to be different? Because of that extra neutron. C13 has one extra neutron. So basically, the energy needed for that particular neutron, what will it be? It will be the difference of these two. So 7.47 multiplied by 13 minus 7.68 multiplied by 12. So whatever answer comes, that is the energy needed for removing that neutron, but that will be in mega electron volt. But I think the answers are in joules also are given, and mega electron volt is also given. So you can convert it into joules if you want. Mega is nothing but 10 to the power 6. Electron is nothing but 1.6 10 to the power minus 19. So this answer will be in joules. If you want it in mega electron volt, you can leave it like that also. But in joules, the answer comes out to be 7.92. Yes, in joules, it comes out to be 7.92. Yep. So when you write it in joules, 7.92 into 10 to the power negative 13 joules. That's what you get. Is that okay, everyone? Don't worry, Vishal, you can watch the replay later on. Sudhir, if you want bit set, please comment later on once the session is over. Yep. Okay. Let's go to the next question. Let's go to the next question coming up on your screen. Here it is. There is a photon which is emitted during the de-excitation of an electron from a state of N to the second excited state of hydrogen atom. It is falling on a metallic electrode whose work function is given with a stopping potential of 0.47, obtain the value of the quantum number of that state n. Okay, first let's solve the photoelectric part, then we'll go to the atomic spectra part. There are two parts of the same problem. Okay, fine everyone. So let's start. First of all, the energy of the photon which is falling onto it is work function plus E times of Vs. Work function is already given to be 0.5 electron volt and stopping voltage is already given to be 0.47. So 0.5 plus 0.47 is nothing but 0.97 electron volt is the energy of the photon. 0.97 electron volt is nothing but the energy of the photon. Now we know in general the energy formula is nothing but 1240 divided by lambda, provided this lambda is in nanometers and this is in electron volt. So if you write it like this will be nothing but 0.97 electron volt. So lambda, if you take it on the top, lambda in terms of nanometers, or just leave it as 1 by lambda only, 1 by lambda will be nothing but 0.97 divided by 1240, but this lambda is in nanometers. Now why is this needed? Because then we can use Rydberg's formula. Okay, now whenever you have lambda in nanometers, to convert it into meters, you multiply it by 10 to the power minus 9. So please remember that I will have to write this as 1 by lambda, and if it is in nanometers, I will write it 10 to the power minus 9 so that it is in SI units. So this is 0.97 by 1240. Okay, take it on the top. So 1 by lambda will be 10 to the power 9 into 0.97 divided by 1240. But since we all know 1 by lambda is nothing but Rydberg constant 1 by n1 square minus 1 by n2 square. So it jumps from a state n to the second excited state. Second excited state means n is equal to 3. So this is nothing but 3. So 3 square, and just substitute this from here. That's it. You will get the answer then. So just substitute this 10 to the power 9 into 0.97 divided by 1240 over here, and over here what do you have? Rydberg's constant. Okay, and then 1 by n square minus 1 by 3 square. So that is basically R. So from this you will get n square. Square root of that will be nothing but n. Is that okay, guys? Yeah. That is how you have to solve this particular question. That is how you are supposed to solve this particular question. So solving this, I think you might get the answer as, if I'm not wrong, some 5 or something. That means n square approximately you will get this as 25, and n you will get it as close enough to 5 units. Now this is a lengthy problem. Such kind of questions you will leave it in the exam. You will solve it towards the end when nothing else is working and you are not able to think about other questions. It's not difficult question, it is just lengthy question. So lengthy questions, try to avoid it in the examination. Moving on to the next one coming up on your screen. Okay, all right, great. What you want me to reply? Sanjana, please make a video on problem solving techniques and understanding. For which exam, Sanjana? Are you talking about JEE Advanced, JEE 2026? What is it that you are exactly aiming for? The velocity of an electron so that its momentum is equal to that of a photon of wavelength 660 nanometers is how much? Come on. This is a direct formula based question. If you get it, it is very simple, guys. Nothing very difficult about it. Direct formula based. The velocity of an electron so that its momentum is equal to that of a photon of wavelength this much. So if the momentums are equal, that is what is given to us. That means momentum of the electron is equal to momentum of that particular photon. Momentum of a photon is nothing but given by h by lambda, and momentum of an electron is nothing but mass multiplied by velocity. So velocity is asked, so it is nothing but h by lambda m. H value we all know. What is it? It is nothing but 6.6 into 10 to the power negative 34. The whole thing divided by mass of an electron close enough to 9.1, 10 to the power minus 31. You should remember that value. Lambda value of that photon is 660 into 10 to the power minus 9 because it is nanometers. You can see this 66 and 66 will cancel. You will get 1 by 9. So 1 by 9 will be 1 point something. So everything is in 1 point something or 10 something like that. So just adjust the powers of 10 and you will get the right answer. Just see how much are you getting this approximately as. See if you are getting it close enough to 1098 meters per second. Yes, just check if you are getting it as 1.098 into 10 to the power 3, which is nothing but 1098 meters per second. Yep. The 66 and 66 will cancel 1 by 9.1, close enough to, yep, 1098. Or, yeah, almost that. Okay. 12th syllabus is decent enough, but not good enough. Okay, so there is a difference. If you want top branches, then not good enough. But if you want okay branches, okay colleges, then it is fine. Cool? All right. The output of the given circuit is a negatively rectified half wave, positively rectified half wave, or negatively rectified full wave, or zero at all times. Very interesting question. See, this voltage is going, this resistance is there, this diode is there. So let's understand what will happen to the output. If there is a positive half cycle, that means this is positive, this is negative. So you're talking about the positive half cycle. So there will be some voltage drop here. There will be definitely some voltage drop over here. So current will definitely flow because it will now be in forward bias. And in the forward bias, the diode, the voltage difference, right? The voltage difference is nothing but going to be negligible. Yes, because it is an ideal diode. So hardly any voltage will be there over here. Almost like 0 volt. Almost like 0 volt will be there. Now let's look at the negative half cycle. This is negative, this is positive. So the current will try to go like this, but it can't because now it will be in reverse bias. So whatever voltage you have applied over here, that exact same voltage will be applied on this because no current is flowing. So there will be a potential difference, but no current is going. It is offering infinite resistance. So that same voltage of Vm will be applied in the reverse bias. So in this particular reverse bias, the voltage is high. In the forward bias, the voltage is 0. So that is what is happening basically. So definitely it is a rectified DC. It is a rectified DC, but it is giving positive values in the negative cycle and negative in the first half. So it is negatively rectified half cycle, you can say. Basically, it means that this part is not rectified, only this part is rectified. Only this part is basically rectified. So the answer will be C, which is A, negatively rectified half wave. Negatively rectified half wave. This part, if it was rectified, it will be positively rectified half wave. That is how the output will be. Lot of students made many mistakes in these kind of questions. Okay. Welcome, welcome, welcome. If you want me to do Amrita College, then please spam the comment after the session is over, not just in this, but other sessions also, because our team investigates all the comments and, based on that, we make these sessions. Because COMEDK students spammed, that's why this session is here. So if you spam 2026, Amrita, WITSAT, obviously those sessions will come. In the intrinsic semiconductors at room temperature, the number of electrons and holes are. Come on, think about it. Oh, by the way, smash the like button for this session if you want me to conduct one more session for Amrita, like a mega mock test. If you want to do that, please make sure you like this video and also comment below this, yes sir, we need one. All right. An intrinsic semiconductor at room temperature, number of electrons and holes are what? Equal. Intrinsic. There is no special adulteration, no doping. So holes and electrons are equal in amounts. So conductivity is very low. It's not as great as extrinsic P or N type of semiconductor. In P type, holes are more. In N type, electrons are more. And we know hole concentration into electron concentration is Ni square. That formula is also given in semiconductors chapter. Okay, great, perfect. Moving on to the next question on your screen. In a given semiconductor, the ratio of the number of density of electrons to the density of holes is 2:1. If 17th of the total current is due to the hole and the remaining 17th of the total current is due to hole and the remaining is due to electrons, the ratio of the drift speed of the holes to that of the drift speed of the electrons is. Very good question. Drift speed question is asked. The ratio of the holes and everything is also given. And basically the question is on figure out what the drift speed is going to be. First of all, let's understand this. If one, I think it is not 17th, it is 1/7 it should be. Okay, I think it is that slash is missing over here. So it is 1/7 of that basically total current is basically because of the holes. The remaining current will be because of the electrons. So let's write that down first. So if the total current, if the total current is basically I, so due to the holes, the current due to the hole will be I by 7. So due to the electrons, the current will be 6I divided by 7. Now, the hole density and electron density is also given. Drift speed is asked. We know there is a formula for drift speed, and current is equal to NVDR. NVDR. Okay, so therefore, I can see that the drift speed is proportional to the current and it is inversely proportional to N. It is inversely proportional to N. E and A are basically constants. All right. So the drift speed of the holes to the drift speed of the electrons, because it is proportional to current, it is IH by IE. And what do we have over here? Inversely proportional to N. So NE divided by NH. Is this absolutely clear, my dear students? Perfect. Okay. So what is IH? IH is nothing but I by 7. What is IE? It is nothing but 6I divided by 7. What is NE by NH? Number of density of electrons to number of holes is 2:1. So this is 2:1. 7 cancels, I cancels. So 1 by 6 multiplied by 2. So it will be nothing but 1 by 3. So the answer will be 1:3, which is nothing but D option. Yes, it is the correct answer. So we have to use this formula. Current is NVDA. A and E are constants for both of them. So drift speed is proportional to current, but it is inversely proportional to N. So current ratio, we can find it out from here. And the rest was just ratio and proportions. Yep. Everyone? All righty. Oh guys, please, if you are giving VIT Triple E exams, please help the other students also, so that it will be helpful for their shifts and their preparation as well. Don't be very selfish. Please tell them if any questions are coming, anything is happening. Please let them know the difficulty, the important topics. Please put it up in the comments so that it stays. A neutral water molecule is placed in a field. The work done to rotate it by 180 degrees is this much. Find the approximate separation of the charges. Now what happens is water is a polar molecule. So whenever you have polar molecules, which basically is an electric dipole, so and dipole placed in a field needs torque and also it possesses potential energy. So to rotate a dipole also consumes work. So let's figure that out. So the work done is change in potential energy, which is nothing but final potential energy minus initial potential energy. 180 degrees and 0 degrees are final and initial states. Final will be nothing but minus PE cos 180 minus initial will be minus PE cos 0. Okay, cos 180 is minus 1, so it will become minus will be plus, so plus P. This minus and this minus is plus, cos 0 is 1, so plus P again. So this will be nothing but 2 times of P is the work done. Electric field is given and to rotate it by 180 degrees is this much. Find the approximate separation of the center of the charges. Now from this, the work calculation is already done. for me. Work is already done. Now the only problem is what will be the charges themselves. What will be the charges themselves? The charges themselves will be the charge of the, or what do you say, electron. So I can just write P as, nothing but electron charge multiplied by the separation. So P is E into D, charge into D. Okay, I'll put over here E, and this is work. Now substitute everything. The work done is nothing but 5 into 10 to the power negative 25. This is 2 into E value is standard 1.6 10 to the power minus 19, and D, which we have to find, electric field is nothing but 2.5 multiplied by 10 to the power 4. So from this we will get the value of D. From this we will basically get the value of D. You can see 2.5 is here, 5 is here, 5 by 2.5 is 2. This 2 and this 2 will cancel. So it will become 1 by 1.6. So basically, numerically speaking, it is 1 by 16. 1 by 16 is like, what do you say, 0.01625 and all that. So 625 will be there in the answer. So either it is B or C. I think it will come out to be B then. So when you solve this, you will probably get it as 0.625 into 10 to the power minus 10 meters. That is the answer. Is this clear, everyone? Yep. As a Vedantu crash course and gave all marks, but felt like the exam was tougher than the previous paper and the mocks. That's why I wanted to know how others felt. Okay. So, like I've been mentioning again and again, most of the times these entrance exams, they are very, very unpredictable. You cannot know what they might do. It's not like NTA, where at least some things are predictable. Okay. Moving on. Figure shows 3 arrangements of electric field lines. In each arrangement, a proton is released from rest at point P. I think the diagram is missing, guys. And accelerated through point Q by the electric fields. Point P and Q have equal separations in 3 arrangements. If P1, P2 and P3 are linear momentum of the proton at point Q in the 3 arrangements, then compare all of them. I think the diagram is missing. I'm so sorry, guys. Let me add this question later on as homework. Okay, I'll just skip to the next question, but I think the diagram was missing. Okay, I'll put it up in the PDF with the diagram later on. 3-point charges are of negative Q and they are placed on the circumference of a circle of a diameter 2a. Okay, diameter is 2a and 3 charges are placed at A, B, C respectively. The electric field at point O. Well, very simple. Due to C and due to A, because the negative charges are there, the fields will be attractive in nature and they will also cancel out each other. So 100% they will cancel out each other. The only electric field which will remain is due to this guy and it will be like this. So this electric field has a formula KQ divided by the distance, which is nothing but A. So KQ by A square. KQ by A square. Electric field is asked. I don't know. I think they missed that point A, and it is towards B. It is basically towards B. The square term in this is missing. So I'll just add that square. I think that was missing over here in all the options. Yeah, now it is fine. So it will be towards B because it is a negative charge. Is this absolutely clear, my dear students? Shall we go ahead to the next question? Coming up on your screen, here it is. When these many electrons are removed from a neutral plate, the charge on the plate will be how much? That's the question. The charge on the plate will be how much? That is the question. Think about it. How are we going to solve? The charge will be positive because you have taken out the electrons, and it will be number of electrons that you take into the charge of each electron. The number of electrons is 10 to the power 19 and electron charge is 1.6 10 to the power negative 19. Plus 19 minus 19 cancels and I will be left with 1.6 coulombs. So 1.6 coulombs is positive charge, which is B option. Many students write negative because they read the word electron and they think it is negative. But if you take out electrons, what is remaining is the positive charge. So please understand it can't be A. Okay, many of you gave the wrong answer also. I saw just now in the chat box, but that happens. So be careful. At least these easy questions do not make mistakes. Okay. Right. Let's go to the next question coming up on your screen. Here it comes. There are three bulbs. They are connected in series. The maximum light is obtained from which bulb? Now, whenever you get bulb questions, I have already told you this. Always think of it like resistance. And we know that power is voltage square by resistance, and resistance will then be V square by P. So resistance is inversely proportional to power. More power means less resistance and inversely related to each other. So out of this 40, 60 and 100 watts is the highest power, so least resistance. So this is basically the least resistance. This is basically the least resistance. And if you ask me who is the highest resistance, that is the 40 watt. So this is basically the highest. This is basically the highest resistance. This is basically the highest resistance. Now, whenever you have resistors in series, the current is basically the same. Current is basically the same. If current is same, the brightness, because that is what the question is, the light which you obtained is basically I squared R, because current is same. It is easier to compare with I square R rather than V square by R, because V will be different. So if you want maximum light, that means I can't be changed. So R only can be changed. So resistance should be maximum. So resistance should be maximum. That means over here, highest resistance. So which bulb was this? This was the first bulb, which is of 40 watts. So the answer will be A, which is 40 watts. Let's check it out. Yes, it is the right answer. Okay. Lot of people I know, they have written the answer as 100 watts because you think 100 watts are more power. Yes, 100 watts will give you more light when connected in parallel, not in series. So in series, it is exactly opposite. Because of this formula, resistance is inversely proportional to power for a particular voltage. So all these bulbs were rated 40, 60, 100, whatever, at a certain voltage, at a fixed voltage. So that fixed voltage is V over here. So the one with highest power has actually the least resistance, and the one with the least power has actually highest resistance. And when you connect these bulbs in series, the one with highest resistance has the highest power using this formula, I squared R. Got it? Okay. Pranav, definitely, my dear, definitely it will be helpful for NEET. Please give it. Okay, moving on to the next question, guys, coming up on your screen. Here it is. There are four resistors connected as shown. What is the total resistance between the points 1 and 3, 1 and 6, 3 and 6, 2 and 4? Now, this is a very sadistic question because the points between which the resistance has to be found is not basically fixed. It is continuously changing from one option to the other. So if you ask me, you have to do it, on the spot only. So if you ask, let's say 1 and 3, Chuma, let's try out some options between 1 and, let's create a duplicate of this. Say for example, between 1 and 3, oops, between 1 and 3, okay, current will go over here like this. It will split, it will come back, but there is a direct wire, so it can directly go like this. So technically speaking, this resistor is not needed, this resistor not needed, this is also not needed, current is not going there. It has directly flown over here because it has now become shorted. It has now been shorted, so there is only one resistance, so it is definitely not 0.5 R, it is basically equal to R. So option A is definitely out of the picture. Similarly, you can go with some other option also. You can try it out. Okay, you can just try it out. What is it between 0.1 and 6? So if you are asked between points 1 and 6, right? So it is going like this. These two are in parallel. Check this out. These two are in parallel, and in parallel resistances will divide, so it will be R by 2, R by 2, R in series, so R plus R by 2 plus R, so it will become 2R plus R by 2, so it will be 2.5 times of R. So it is saying between 1 and 6 is 3.5 R. No, it is 2.5 R. So B option is also out. Similarly, you can check C and D also. I will check reverse also, maybe the total resistance between points 2 and 4. Between the points 2 and 4, let's check that out. Let's see how it comes out to be. Between 2 and 4, for example. So current is going like this and it is coming out from here. So if that happens, this resistor is useless, this is also useless, and this current which comes inside, that will get distributed here and here. It will go like this, like this, like this, and it will come out from here. Okay, so these both are in basically parallel. So if they are in parallel, so the equivalent will be just R by 2. So that is 0.5 R. Oh, coincidentally, it is matching. So I think D option will be correct and C option will be wrong then. Yeah, so if you try out C option, that will be definitely wrong. C option said between 3 and 6. C option was between 3 and 6. You don't have to try it out. Chumma, I'm just saying if you try it out, it will be wrong. This resistor will be useless. The current which enters into 3 will go from here and here like this, and it will go like this, like this, like this, like this, and come out from here. These two are going to be in parallel. So it will be again R by 2. It is in series with this. So it will be R plus R by 2, which is nothing but 1.5 R. So this is definitely wrong. So all the three options, first three were wrong. A option was wrong, B option was wrong, C option was wrong. Only D option is correct. So this is very sad because usually we'll try out checking one by one from the top and the last option comes out to be correct. Yeah. Is that right? Okay, IIT, we are definitely going to conduct next also, definitely. There is still time for that, but we'll definitely do it over here. Make sure it is bonus and expect some bonus questions in COMEDK KCET. Last year, they gave some 20-30 bonus questions randomly. Okay, so that was very weird and very strange also. An electron starting from rest and moving with some speed through a voltage difference is shown by the graphs below. Which of the graph is basically correct? Electron is starting from rest and the speed versus the potential difference. See, whatever potential energy is there, that gets converted into the kinetic energy. Potential energy is charge multiplied by the voltage difference. Okay, and kinetic energy is half mv square. So essentially, v square will be 2q divided by m multiplied by delta v. So speed is root of 2q by m and root delta v. So speed is directly proportional to root delta v. So it's just like saying I have a graph of y versus root of x. Y versus root of x. So what is what over here? Y versus root of x, or basically y square is proportional to x. Y square is basically proportional to x. Which of these graphs will be, guys, then correct? Just think about it. Y square is proportional to x. When y is proportional to x square, then the graph is like this. When y square is proportional to x, then the graph is like this, isn't it? Then the graph is like this. It is a horizontal parabola, not upward or downward parabola. So hence the answer will be C, if this is speed and this is potential. Yep. Is this absolutely clear? Very good, Shweta. Yep, option C is the right answer. Very good. Excellent. Moving on to the next question on your screen. On increasing the temperature of a conductor, the resistance increases because for a semiconductor, it is exactly opposite. When you increase the temperature, the resistance goes down. This is a conductor. When you change the temperature, automatically you will see the resistance also increases. Why? It's because the collisions between the electrons decrease, relaxation time decreases, relaxation time increases. What do you think? Yep, there is a formula. Drift speed is E by m into t, and current is equal to NVDR, and voltage is equal to current multiplied by resistance. These three equations are good enough. When you increase the temperature, resistance increases. If resistance increases, current will decrease. So if current has to decrease, the drift speed has to decrease. If drift speed decreases, the relaxation time has to decrease. So the relaxation time decreases using this equation. Go reverse. Ohm's law, current is NVIDIA and VD is EE by M into tau. So automatically It's understood that the relaxation time decreases because more frequent collisions will occur. Yeah, they will collide more frequently. It is difficult for the electrons to conduct within the body of the electron. Correct? Moving on. There is a negative charge particle and it is moving up in a magnetic field which is towards the north. The particle is deflected towards which direction? There is a negative particle. It is moving upward in a magnetic field which is towards the north. Okay. So see guys, our north direction is over here and this is exactly where the magnetic field is, in the north direction. Okay. This is east, this is west, this is south. And it is coming up. That means the velocity is basically towards you. So the velocity vector is towards you. So if you do V cross B, because force is V cross B, V is towards you, cross B will go left side. So velocity crossed with the magnetic field, this direction is definitely towards the left side, using, that is towards the west side, using the right hand thumb rule. Velocity of towards you cross field is left side, but that is for the positive charge. For a negative charge, it will be exactly like this. So this is for a negative charge. It will be basically towards the east side. It is clearly mentioned it is a negative charge. So the answer will be east side, option C. Is this absolutely clear? The formula that we have used is nothing but force is charge into your velocity cross magnetic field. Velocity cross the magnetic field. So whatever V cross B is there, if you multiply with a negative sign, it will be opposite. Or think of it like the left hand rule. Is that okay, everyone? Many people will write the answer as west because you will forget the charge was negative. So be careful. Next one. There is a wire of certain length carrying some current along the x-axis. Magnetic field is there in ijk. The magnitude of the magnetic force on the wire is. So I'll tell you something. When you write the magnetic force, it is basically IL cross B. So if the length of the conductor is parallel to the magnetic field, then the force on it is 0. So only certain components are responsible for the force. First is the J component and next is the K component, because as you can see, the wire is along the x-axis. So the magnetic field along the x-axis will not give any force. So the force due to the Y component will be the current multiplied by the length. Length is how much? 2 meters. Multiplied by the magnetic field, which is nothing but B naught. Similarly, force due to the Z component will be current multiplied by length, okay, and the magnetic field in the Z direction. So both times it is 2 V naught. So what will be the net force? Net force technically is Fx square plus Fy square plus Fz square. Is that right? But we all know that the X component of the magnetic field did not participate. It was basically 0. So only these two were there, and that was nothing but 2B naught. 2B naught, and this was also 2B naught. Is that right? So whole thing under the root. Okay, so what will this be, guys? It will be 2 times B naught root 2. So the net force is 2B naught root 2, which is option D. This X component did not participate because cross product of parallel vectors is always 0. Even anti-parallel, it is 0. Pranav, yes, you will be getting the PDF, but not now, later on. Okay, great, perfecto. Let's move to the next question coming up on your screen. Here it is. A charge of 1 coulomb is moving with certain velocity through a region where the electric field is so and so and the magnetic field is so and so present. The force experienced by the charge is how much? The force experienced by the charge is how much? Charge is given, velocity is given, electric field is given, and magnetic field is also given. There is two types of forces, electric force and magnetic force. So the electric force is chumma, just Q into E. So charge is 1 coulomb and electric field is how much? I cap plus J cap minus 3K cap. So it is just I cap plus J cap minus 3K cap. So just keep it as it is. Now for the magnetic field force, you will have to do V cross B. So velocity is okay, just use this matrix multiplication, sorry, determinant method, my bad. So this will be 2, this will be 2, this will be minus 1. Magnetic field is 1, minus 2 and 3. Okay, so just put I cap over here, then there will be minus j cap over here, and then there will be plus k cap over here. So for I cap, forget this column and row. So 2 3s are basically 6, minus 1 into minus 2 is 2. So this will be minus 2. Similarly, forget j column and row. So 2 3s are again 6, minus 1 into plus 1 is minus 1. So just put minus 1 over here. Okay. Then for k cap, forget this and forget this. 2 into minus 2 is minus 4, minus 2 into 1 is basically 2. So just put 2 over here. So this will become basically 4 I cap plus 1. 6 plus 1 is 7. So minus 7 j cap. And this will be nothing but minus 8 k cap. Now this is V cross B. So the force due to the magnetic field, which is Q into V cross B, charge is 1 coulomb. So exactly this answer will come. So 4 I cap minus 7 j cap minus 8 k cap. So now to find out the net force. So now the net force will be because of both of them. So I plus j minus 3k plus 4i minus 7j minus 8k. So when you add both of them, this will become 5i cap, this will become minus 6j cap, and this will become minus 11k cap. So that's it. So that is what the answer should be. None of them are matching, some mistake unless or the options itself are wrong. Just check it out. Somebody is saying B is Shweta. Is that so? Just check it out. Unless we have done some mistake over here. Yep. So just see if V cross B is correct. 4 I cap minus 7 J cap minus 8 K cap. Just see if everything is fine over here. 2 and I think we made a small mistake here. This was not minus 8 K cap. This was minus 6 K cap. Sorry guys. 4 minus 2. This is 6. So minus 6 K cap. Okay. This is also minus 6 K cap. Oh my God. What is this? Okay. So here also put this as 6. Then I think things will be better. So this is minus 6 K cap. So this will be minus 9 K cap. Just check this out. Minus 9 K cap. Yep. So option B seems to be the right answer then. Then option B, yes, option B seems to be the right answer. Yes, perfect. Is that okay, everyone? Yeah. So 4 minus 2, 4 plus 2 is 6. So 6 we had to put it over here. So now it is perfectly fine. Yep. Very good. Yes. Thank you so much. Let's move, guys, to the next question coming up on your screen. For a paramagnetic material, the dependency of the magnetic susceptibility on the absolute temperature is given by. This is called as Curie's law. And Curie's law says that susceptibility is inversely proportional to temperature. And the graph also looks like this for a paramagnetic material. For a diamagnetic material, it is independent. For ferromagnetic material, there is a Curie's temperature. So after heating it till that temperature, after that it becomes paramagnetic. So that is for ferro. So it is inversely proportional to temperature. That's it. Very simple. D option. Nothing great. Direct Curie's law. Is that okay, everyone? Perfect. Let's go, guys, to the next question on your screen. There is a bar magnet which is held perpendicular to the field. If the couple acting on the magnet is to be half by rotating it, the angle by which it has to be rotated is. So see, if there is a bar magnet and it is perpendicular to the magnetic field, okay, so this is the magnetic moment, the torque acting on it is mb sine of 90. Sine 90 is 1. So it is basically mb. Now, what is the question? The question says that the coupled torque acting on the magnet has to be halved. So the torque has to be, the new torque has to be old torque by 2. That means it has to be mb by 2. So that will happen if it is mb sine theta. Okay. So MB cancels. So half is equal to sine theta. Half is equal to sine theta. So therefore theta is nothing but 30 degrees. So theta is nothing but 30 degrees. So nothing but the new angle which the magnet should make, the new angle which the magnet should make with the field, this angle should be 30 degrees. But the question is the angle by which it should be rotated. So be careful, that is not the answer. So the angle by which you will rotate it is basically 60 degrees. The angle by which it has to be rotated. So the correct answer will be C option. Many people will mark B option, be careful. No, the correct answer to this will be C, because the question says by what angle will you rotate it? That was the question. Is this absolutely clear, my dear students? Let's go to the next question on your screen. Here it is. If the percentage change in the magnetic field when the space within the current carrying solenoid is filled with a medium of susceptibility is so and so, what is the change in the magnetic field? Well, the magnetic field inside a solenoid is mu naught Ni usually, but when a material is added, you put relative permeability. And what is relative permeability? It is always 1 plus susceptibility. Relative permeability is 1 plus susceptibility, so into Ni. So essentially it is mu naught Ni plus mu naught susceptibility into Ni. So this is basically the magnetic field which is new one. So the question was, what is the percentage change? So the question was, what is the percentage change in the magnetic field? So it will be the new magnetic field minus old magnetic field upon the old magnetic field. New is nothing but mu naught Ni plus mu naught susceptibility Ni minus old will be just mu naught Ni only. The whole thing divided by old one is just mu naught Ni. This whole thing multiplied by 100. So what will this be? This and this will cancel. So I'm just left with mu naught xni divided by mu naught Ni multiplied by 100. Is that right? So mu naught Ni cancels. So I'm just left with x multiplied by 100. So what is x? X is basically 0.004 multiplied by 100. So this will be nothing but 0.4%. So 0.4%, which is D option. Is that clear, everyone? So this is how you are supposed to solve it. When you add some material, what will happen is the susceptibility will change the permeability. Permeability will change the magnetic field. So this was the formula. Permeability relative is 1 plus susceptibility. Great. Let's go, guys. Transformer which is efficient 100% has so many turns in primary and secondary. It is connected to this supply. Secondary feeds to this much resistance. The potential difference per turn is how much? The potential difference per turn is how much? Okay. We know one thing. Number of turns in primary upon the secondary will be primary voltage by secondary voltage. Primary has 200 turns. Secondary has 40,000 tons. Primary voltage is 220 and this is nothing but secondary voltage. Now the question says the potential difference per turn. So how about rearranging it here only? V2 on the top, and this is 40,000 tons, sorry, 40,000 tons is nothing but 220 divided by 200. This is voltage per turn. So that's it. That is what we need. 0, 0 cancels. So 22 by 20, which is 11 by 10, which is nothing but 1.1. So the answer is 1.1 volt per turn. So this is 1.1 volt per turn. As you can see, this is the number of turns over here in the secondary. So the answer should be D. Perfect. Can you see that? A very differently framed question, very unique question which has been framed, right? Let's go, guys, to the next question on your screen. The magnetic flux is given. The EMF in the coil in the third second, they have asked. Okay. So when they ask you such things, use delta phi by delta t. The time interval will be 1 second. Here you will have flux in the third at t is equal to 3, and here flux at phi is equal time is equal to 2. That's it. And the time interval will be 1 second. So what is phi 3 and what is phi 2? So just substitute respectively. Phi 3 will be put time as 3. So 8 into 3 square plus 3 plus 10. Okay. And 5, sorry. So how much will this be? 3 square is basically 9. 9 8s are, right? 9 8s are 72. Okay. And plus 3 plus 10, which is basically 13. All right. So this is nothing but 85. So 85 is the first number over here. Similarly, find phi 2 over here, which is 8 multiplied by, put the value of time as 2 plus 2 plus 10. 2 square is 4, 4 8s are 32 plus 12, which is 44, right? So put 44 over here. Is that right? So you will have 1 and you will have 4. So 41 volts, that should be the answer. Just check this out. 41 volts. Yes, this should have been the answer, but none of them is matching unless we have made some mistake over here. Just check this out. Yeah, this was the flux. Time in the third second is asked. Flux in the third second is asked. So this should have been the correct answer, my dear students. Okay, I think they have made a mistake somewhere. Just check this out. Phi 3 minus phi 2. 32. Yes, perfect. 2. This is 3, 10, 85. Yes. Yeah, it should have been 41 volts. Yeah, it should have been 4. Can we use EMF as the rate of change of flux and put? No, no, no. Don't do that. That is wrong. So this method is definitely wrong. EMF is equal to d phi by dt and substituting t is equal to 3. This is not what this is. This is 100% wrong. This is the third second. So the interval of time is 1 second. This is what it means. So third second means from t is equal to 2 to t is equal to 3 seconds. So the interval becomes 1 second. So the correct answer should have been 41, guys. Okay. I hope this is absolutely clear. So I think we will have to change this over here or else it won't make sense. So this should have been 41 volts and then this will be the right answer. Okay, perfect. I hope, Shweta, it is understood why you cannot do that, because that will give you the instantaneous EMF at 3 seconds, not the average value. Next one. There are devices having power rating of 500 watts. Voltage is also given, and the RMS value of the circuit current is. Okay. 500 watts is the power rating. Okay. Voltage is basically 200. What is the RMS value of the current? What are you going to do in such a question? Think about it. What are you going to do in such a question? See, I'll tell you what. Just find out the resistance, you will get the answer. Power is nothing but Vrms square by resistance. And we also know that the Vrms into Irms, Vrms into Irms is also basically the power, or you can just say Irms square multiplied by the resistance is nothing but the power. So if I want Irms, so we'll try to get rid of R. R is nothing but P by Irms whole square. So substitute this R over here. So it will be power divided by Irms whole square. This is below. So that is Vrms square. Correct? So this is P. So it will become basically P square is Vrms square into Irms square, which means P is nothing but Vrms multiplied by Irms. So that is what our usual relation should have been at the end of the day. So basically we have 500 is equal to ERMS is, or VRMS will be nothing but 200 by root 2. So this is into IRMS. So how much is IRMS going to be? 0, 0 cancels. So I will have 5 by 2 and root 2 will be on the top. So this will be 5 by root 2 ampere. Now root 2 is 1.414, 1.414. So, you can just think of it as close enough to something like 3 point some amperes. But the question was, what is the RMS value of the current? RMS value is this. This was the peak voltage. So none of the options are matching unless the question itself was, what is the peak value of the current? If the question was, what is the peak value of the current, then the answer would have been just 5 amperes. So if this was not RMS, if this was the peak value, then the question would make sense. What is the peak value of the current? So then I will say that the peak value will be whatever is the RMS multiplied by root 2. So then it will be 5 amperes. Then this option would have matched. Then this particular option D would have matched. Okay. Moving on to the next question on your screen. There is an electromagnetic wave and it is going through a dielectric medium of some relative permittivity, okay, of this much. Then the wavelength is half, frequency is double, frequency remains unchanged, wavelength and frequency remain unchanged. You can directly mark this. Always frequency remains unchanged. Frequency remains unchanged. Frequency is doubled wrong. Frequency remains unchanged. Frequency remains unchanged. Frequency doubling is definitely not an option, because there is some dielectric medium and relative permittivity is given. That means speed will change. If speed changes, wavelength will change. So saying that the speed will not change or wavelength will not change is wrong. Wavelength remains unchanged is definitely wrong. So if you ask me what is the new speed, it will be 1 by root of permeability into permittivity into relative permittivity over here. So that is nothing but root of mu naught epsilon naught root of 4. So it is nothing but speed of light. Root of 4 is nothing but 2, because this number is speed of light. So essentially the new speed of light is half the original speed, and we know speed is frequency multiplied by wavelength. So if this becomes c by 2, frequency will still remain the same, wavelength will become lambda by 2, so that the equation is maintained. So the wavelength should become half. So the wavelength is half is correct. Wavelength is doubled is wrong. Speed becomes half, wavelength becomes half. So D option will be the right answer. D option will be the right answer. Frequency is always the one which will remain constant. Is that okay, everyone? Perfecto. Shall we go ahead to the next question on your screen? Here it comes. If an electron from the hydrogen atom jumps from the third orbit to the second orbit, the wavelength is lambda. When it jumps from the second to the first orbit, the wavelength will be how much? Okay. So first time lambda is Rydberg's constant. It is jumping from the third orbit to the second orbit. So that means 1 by 2 square and 1 by 3 square over here. So it is nothing but R. 2 square is nothing but 4. 3 square is nothing but 9. So after LCM, it will be 9 minus 4 upon 4 into 9. Okay, so it will be nothing but 5R by 36. That is 1 by lambda. Now let's go to the second part. What is the wavelength? Okay, so I don't know what is that wavelength, so I'll call it lambda prime. When it jumps from second to the first orbit, so 1 by 1 square minus 1 by 2 square. So LCM will be 2 square and 1, which is 4. So this will be 4 minus 1, which is nothing but 3R by 4. So that is 1 by lambda prime. So just divide both of them, or just take the value of R from here and substitute it, you will get the answer. So from this you will get R is nothing but 36 by 5 lambda. Just substitute it over here, because lambda prime will be 4 by 3 times of R. So 4 by 3, and instead of R, you are just going to put it as 36 by 5 lambda. That's it, 36 by 5 lambda. So now you can easily get the answer. So new lambda will be 4 goes with 36 9 times. So 5 lambda, 9 3s are 27. 5 lambda by 27, which is option number A. Okay. Yeah, the PDF will be uploaded by evening. Don't worry. Okay, cool. Moving on to the next question coming up on your screen. I think we just solved this question by mistake. It came, no issues. I'll just add another homework question then, because this is the last slide which we have. Yep. So I'll add 1 or 2 more questions in the homework so that you can practice it additionally. Okay. So that's it for today. I hope you enjoyed the class. More sessions if you want for COMEDK, please let me know. These are the models and difficulty level that you can expect for COMEDK. Leave a comment on which other exam model questions you want, and high weightage topic expected models you want for the required examination. That's it from my side. Thank you so much. This was Captain Shreyas signing off.